So here's a quick review of how to graph polynomials. And again, as a reminder, the name of the graph is called a parabola. So as a review, we talked about a being the number in front of the quadratic term, the term that's to the second power, is called the leading coefficient. B is also a coefficient, but it is not a leading coefficient because it's not in front when the quadratic is in standard form, with the term with the highest power first, then bx. And then last was C, which was our constant. So anytime that you're given a quadratic equation in standard form, so I'm just going to make up an example here. It's often helpful, maybe we'll make this, sorry about this, we'll make this minus 8. It's often helpful to pull out what A, B, and C are. So, if you want to, you could even highlight. I see A is 2, B is 8, and C, my constant, is negative 8. So 2, 8, and negative 8. We look to our leading coefficient. If this guy is positive, which in this example it is, our parabola is going to open up. If A is negative, our parabola would open down. The first thing that we found when we were trying to graph was our y-intercept. Now, keep in mind that y-intercept is a point, so it's going to have an x and a y coordinate, right? X coordinate, y coordinate, and it's going to be the place where it crosses the y-axis. Now the nice thing is, to find the y-intercept of any graph, you simply have to plug in 0 for x and solve for y. So if I did this, plugging in 0 everywhere x is, I end up getting 0 plus 0 minus 8, so I get y equals negative 8. So this is my y-coordinate, negative 8, when x is 0. And we always plug in 0 for x when we're trying to find the y-intercept because it's on this y-axis, and every point on the y-axis, its x-coordinate is 0. So if I have 1, 2, 3, 4, 5, 6, 7, 8, there is the point 0, negative 8, called my y-intercept. Where my parabola is going to go through that point. It's going to cross the y-axis right there. So that was the first thing that we talked about. The next thing that we talked about, which is something that we discussed today, was how to find the middle of our graph. How do we find an imaginary line called the axis of symmetry that travels right through the center of our parabola? Now the axis of symmetry is not a point, so it's not going to have an x and a y coordinate. Instead, it's a vertical line. So we know that vertical lines are always x equals some value. So we have to find what that value is. To find the axis of symmetry, we used a formula. I'm usually not too keen on them, but so the formula is that our line is going to equal the opposite of b over 2a. Now what do I mean by b and a? Here we are up here. Opposite of b, b is that middle coefficient right there. A is the leading coefficient. So if I do that for this specific problem, I get that b is positive 8, so the opposite of b would be negative 8. 2 times my a value is 2. So I get negative 8 divided by 4. So x equals negative 2. So this is going to be, remember, a vertical imaginary line. Now I'm saying imaginary because it's not actually going to be on our parabola, okay? A parabola just is U-shaped, but it can have an imaginary axis. Like if you were to fold this parabola in half and want both halves to match up, you would fold it on the axis of symmetry. So in this case, I get that at negative 2, which is right here, I'm going to have this imaginary line. Anytime you graph a line, it's always good to put its equation. So down here, I'm going to put x equals negative 2. That is my axis of symmetry. Now the axis of symmetry won't be the same for every equation because our b values and our a values aren't always the same. So it's not always going to be negative 2. But with y-intercepts, you know you can always plug in 0 no matter what the equation is, and that your y-coordinate will always end up being just your constant. Those are kind of some shortcuts. So the last thing that we found today was our vertex, and this is our highest or lowest point on our graph. So in this case, this point here would be our vertex. Our vertex is a location, it is a point, so it does have an x-coordinate and a y-coordinate. So it is a coordinate point, so we've got to find its x-coordinate and its y-coordinate. Now the good thing is if you already found your axis of symmetry, your vertex is going to be on that axis of symmetry. So you already know to plot your vertex that you have to go over to your axis of symmetry. So in this case, since my axis of symmetry, was negative 2, right away, bam, we're halfway there. We have our x-coordinate of our vertex. In order to find our y-coordinate, the y-coordinate, well, we're just trying to find this guy's partner. Anytime you have an x value and you're trying to find y, you just plug in this number for x into your equation and you solve for y. So my equation is y equals 2x squared plus 8x minus 8. So now I'm going to take this negative 2, don't lose the negative, and I'm going to plug it in here and here. So I get 2 and then parentheses negative 2 squared since it was x being squared. Let me zoom in here. Plus 8 times negative 2 minus 8. So all I'm doing is plugging in my x-coordinate, trying to find what the y-coordinate is. So using order operations, I do exponents first, so negative 2 squared is 4, positive 4. Negative 2 times 8 is negative 16, so I could have just written this as minus 16. So I have 8, take away 16, take away 8. 8 take away 16 is negative 8. Then I have minus 8. So I get that y equals negative 16. So that's the partner there for negative 2. That's my vertex. That's, in this case, going to be my lowest point since I know my graph opens up. Alright, so if I go back over my graph, the point negative 2, 5, 10, 15, 16, way down here is going to be my vertex, which is negative 2, negative 16. Now we're going to finish tomorrow finding some other points. In fact, we're only going to need one other point in order to draw our parabola. And we will be done with graphing parabolas that are in standard form. So anytime there's no parentheses in your original equation, it's written in this form here. This is called standard form. All right, if you guys have any questions, please feel free to come in the morning. I'd be happy to help you finish up that worksheet from yesterday.